All of these reactions need a what?
Energy of activation.
Energy of activation. What else?
Sufficient energy.
Energy of activation. What else?
Oh, they need to be in the right. They need to be in the right order.
To be in the right or the correct orientation. Okay. All reactions need this minimum amount of energy called energy of activation. Let's say I say this is 10, 15, 20, 25, 30, 35. I want you to calculate the energy of activation for this reaction. And the change in energy, and tell me if it is exothermic or endothermic. Here on this side you have energy in kilojoules per mole. And here we have reaction coordinate. What happened? All right. So what is energy of activation?
The difference of the
Difference
transitional
between-
phase and the reactance.
Transition state minus reactance. What's this number here in this case?
40 minus 15.
40 minus 15, which is 25 what? Kilojoules per mole. Can this number ever be negative?
No.
No. It could never be negative because after the reactant there is always a hill. Okay? It could be negative if it were like this. Yes? And that doesn't exist. Okay? Does not exist. So energy of activation is always a positive number. Why is it always a positive number?
Because you're always subtracting like a greater amount of energy from a lower amount of energy.
Why is it a positive number, man? Don't you watch the videos? Not my videos. Somebody else's videos. Don't you watch them? So what the deal is? Why is energy of activation always a positive number? Yeah, sure, it is endothermic, but why? Why is an explanation?
Because products are higher than reactants.
Absolutely not.
No,
It's an energy that you can put
Oh,
into a system.
Yeah.
Why?
Yeah, no.
Okay? It is the required energy to break bonds, yes? Before you can make a new one, and I said this 10 times last time. I don't understand how I repeat something 50 times you still don't get it. Maria, you get it? You do? Okay, very good. And what's the change in energy here? Change in energy is products minus reactants, yes?
Yep.
Is this a product, yes or no?
Yeah.
How do you know this is a product? By convention, yes? The ones on the left-hand side are reactants. The ones on the right-hand side are products, yes? So, products minus reactants, the product is 25, minus the reactants, which is 15. It's equal to what? 10? Very good. I'm glad you guys are here to do the math for me, otherwise I'd have a problem. So, is this positive or negative? This is positive, and what does that mean when it is positive? This is referring to whether it is exothermic or endothermic. This is endothermic, and if we're going to use total energy or Gibbs free energy, the word that we use for that is
Organic.
exergonic or endergonic. This happens to be endergonic. And as you can see, This endergonic has a G in it, yes? All right. And if it is endothermic or endergonic, what does that mean?
It's non-functional.
Energy went into the system.
Okay, it means that, it means what?
Products are less stable in reactants.
Okay, that's one of the things it means. As far as the stability is concerned, you can see it here, yes? The lower energy, the more stable it is. This is higher, so it is less stable. What else? It requires energy, yes? It has to get an energy from somewhere. They all required an energy to begin, yes? But this is an energy requirement of that much for that to occur. Okay? Where does that energy come from? Where does that energy come from? The energy for this or the energy for that? Where does it come from? It comes from the environment. It could come from outside heat. And if it's too large, does it occur? No, you gotta heat this stuff up, yes? So if the energy requirement is too big, then the reaction might be slow or not occur at all. So if we go from reactants to products, the reaction went forward, yes or no? Forward. Okay? But if the reaction goes from products to reactants, then the reaction went reverse. Very good. Some reactions go forward and then reverse. Those are equilibrium reactions, which we're going to have in the next chapter. So, what we have been calculating here is an energy of activation for what? For what process? Forward or reverse? Forward. So we're going to call it FWD. And this change in energy is for the forward process. So let's say I want the energy of activation for the reverse reaction and the change in energy for the reverse. I want you to calculate it and tell me what it is. What's the energy of activation?
15 kilojoules per mole.
Energy of activation is what?
15 kilojoules per mole.
15?
Yeah.
You say energy of activation is 15 kilojoules per mole. So, when we are going in the reverse direction, yes? What does that become?
Those
The
reactants.
reactants. So if I'm going in that direction, that becomes the reactants and these become the product, yes? Still, if these are reactants in the reverse direction, that is still the transition state. So we are still doing transition state minus reactants. I do not want you to say transition state minus product for reverse. If someone tells you that, you tell them no. Because energy of activation is defined as what? Transition state minus reactants, period. Okay? Some of you will say, oh, it's easier if I remember it this way. I don't care what you think is easier. This is the only way, okay? Yes? This is the right way. So if I am going that way, these are reactants, and that is transition state. Transition state is still the same, it is 40, yes? Minus the reactants, which is 25. So what's that equal to? Huh? 15? 15 kilojoules per mole. Positive number or negative number? Positive number. Could this number ever be negative? Whoever gets this wrong on the test, I'm going to smack you in front of everybody. Change in energy for the reverse process. What is it? Tell me the equation. No, equation.
Products minus reactants.
Products minus reactants. Because it's reverse, should it be reactants minus products?
No.
It is always products minus reactants. If you start putting reactants minus products, you will be confused and you won't know what to do later. Always products minus reactants. But in the reverse direction, those change, yes? What are these in the reverse?
Reactants.
Those are reactants. So products, these are the products, yes?
So it becomes
15 minus
25.
reactants, 25. What is it?
-10.
Negative 10 kilojoules per mole.
That's
Notice that delta E for the forward process and delta E for the reverse process is the same number
this
but
one
with
is
a different
exothermic.
sign, yes? So if it is endothermic going this way, it will be exothermic going that way. Okay? Now how about the energy of activation? Is the energy of activation the same?
No.
No. The energy of activation for the forward and the reverse process are two different numbers, but they are both what? Positives or negatives?
Positive.
They're both positives, okay? So if I tell you, okay, you listen up, okay? If I tell you that the energy of activation for the forward process is 40 kilojoules per mole, and the energy of activation for the reverse process is 30 kilojoules per mole, is this reaction endothermic or exothermic?
And
So, it's endothermic.
they have the same one.
No. It's endothermic.
I'm gonna repeat it, okay? Maybe you should write it down so you don't have to use your brain that much. When their energy of activation for the forward process is 40 kilojoules per mole. Energy of activation for the reverse process is 30 kilojoules per mole. Is this reaction endothermic or exothermic, and by how much? Right, but I don't want you to say something, I want you to know how to get there, yes? Good morning, my friends.
Good morning.
I'm glad you are never late, okay? You are never late, I know.
So you asked what's the difference?
Guys, how much is it? Endothermic or exothermic?
It's exothermic. Changing energy is -10.
What do you think, Miss Rodriguez?
It looks just like that.
You having a bad day? Okay. Forward is how much?
40.
Look, you put the reactants, yes? You don't know where they are. But what I know is that forward it is 40, yes? From here to here. This is how much?
40.
This is 40. And then the next one is the one that is for reverse, yes? And that is how much?
30.
30. So is 30 less than 40 or more than 40?
Less.
Less than 40. So that means that the difference between here and the other one has to be on top of this line, yes or no?
Yep.
Because it's a lower number. So that will end before. So this one from here to there is 40 kilojoules per mole. And from here to here, this is going to be 30 kilojoules per mole. Yes or no? Big number, smaller number. So what is the difference between here and here?
10.
The difference is 10. Because if the whole thing is 40, and I take out 30, I have 10 left. 30 plus 10 is the whole thing, which is this plus this, and this is 10 kilojoules per mole. Is the reaction endothermic or exothermic? The reaction is endothermic. And the change in energy is equal to 10 kilojoules per mole. Yes or no? That's on the test. You want another one? You do? Are you guys studying already for the next exam or not yet?
Yep.
Not yet? Do you need an incentive to study for the test?
No.
I'll give you one. I'll give you a quiz next week if you want.
No.
Sure. I give you more points.
Nah, man, you don't watch my videos. You watch somebody else's videos. In my book, your name is LeBron James. That's cool. So, all right, let's do another one. For the forward process is 80 kilojoules per mole. Energy of activation for the forward process is 80 kilojoules per mole. I said energy of activation, yes?
Yes.
Energy of activation for the reverse process is 100 kilojoules per mole. Draw the diagram and say if it's exothermic, endothermic, and by how much.
100. 80. Wait, no.
It's gonna get more complicated now, okay?
Forward is 80. Reverse is 100. Just wants to know like the same question.
Guys, it doesn't take that long. Why are you guys writing so much? What are you guys writing about? Boyfriend's name? You're writing a letter to your boyfriend? Love letter. So how much is forward?
80.
Forward is 80?
80.
So I am going to go like this. I don't know how much 80 is, but I gotta tell you. That is 80 kilojoules per mole. And the next one is 100. Is 100 bigger than 80 or smaller than 80?
Bigger.
Bigger. So that means that the line, when I drop it down, is gonna pass this point because it needs to be bigger than 80. So I am going to go like this, and it passed the point, so it doesn't really matter where it did it. But from here to down here, it is a bigger number, and this is how much? 100 kilojoules per mole. Now the difference between these two is how much? The total thing is 100, and if you take that piece out, that gives you this. So it is how much?
-20.
Huh?
Next.
Negative 20. 100 minus 80 is negative 20.
No, it's 20.
No, I don't know. I'm asking you.
It is.
This number right here is what? I want you to tell me mathematically. Is this minus 20 or is this 20? It's 20. Okay? 20 kilojoules per mole. That is not a minus 20. That is a 20. Now what you have to notice here is that it is products minus reactants, yes? Yes or no? And when this line here is below, is it more stable or less stable?
More stable.
More stable. So you are subtracting a little number, and that is bigger than this number down here, yes or no? That means this is exothermic. So when you are calculating this delta E, the difference it is 20, but the delta E is minus 20 for the forward process. So this reaction is exothermic or exergonic. Okay? Very quickly, is this reaction endothermic or exothermic? Endothermic, that line is higher. This reaction is exothermic. Reaction lower for the product, exothermic. Okay? Let's do another one. You want another one, or is that, you understood that from that? You understood it from that? Okay, let's still give you another one.
Is there anything, I have a question. Is there a reaction where the energy of the product is the same as the energy of the reactants?
Very unlikely. They could be very close, but exactly the same, very unlikely. It could, there's no reason why it cannot, but it's difficult to break some bonds and make someone, and that they won't, that everybody's gonna have the same stability. It's difficult to have that. Okay, ready? Change, energy of activation. Energy of activation is 75. Let's make the math difficult, yes? 75 kilojoules per mole.
Forward?
Is it forward or reverse?
Forward. 75 kilojoules per mole. Delta E for this reaction is 15 kilojoules per mole. Draw the diagram. You said you understood it, so now show me. In fact, show yourself. 15, yes? 75 and 15. You taking a picture of her notes? Huh? What in the world is going on? Guys, you get the notes from my secretary?
Not yet.
So, what's the question here? What was the question?
Draw the diagram.
Draw the diagram. Okay, so draw the diagram. Give me the energy of activation for the reverse process. And give me the change in energy for the reverse process. I'm getting tired. This is hard work. It's not like, construction work is difficult. Construction work is easy. So what's this? Tell me. How do I begin this drawing? I start at what? I start at 75?
You said,
75?
no.
What do I do?
You start at 15 and
I start at 15? I could start at 100 if I wanted to. Where do you start, my friends?
It doesn't matter.
You don't start, you just go like this, line. No number yet, right? Because it's a difference between numbers. This could be 75, 50, 100, 300. So line, then what?
Up. Down.
I go up, yes? Why is it that I go up? Ms. Rodriguez, why is it that I go up? Because up is better, yes? Okay. I go up because energy of activation is a requirement, yes? Of energy. So it goes up. And the difference between here and here is how much? 75. Very good. I got that out of the way. And then the next thing is? What's the next thing I did?
Changing energy.
Changing energy, which was? So,
15.
for this, energy of activation was 75 for the forward process. And changing energy was what?
15.
For the forward process, it was 15. Positive or negative?
Positive.
Oh. If it is positive and the reaction is endothermic, is the next line going to be above or is the next line going to be below for the product?
Above.
It's going to be above because above means endothermic. So I'm going to draw this line above this one. Clear? I drew this line above because it is endothermic. I'm going to draw it here. Yes? And I'm going to say this thing came down to that. The whole thing is 75, and the difference between here and here is how much? 15 kilojoules per mole. So if I am going in the reverse direction, how much is from here to here? Whatever you add to this has to add up to how much? 75. So 15 plus what gives me 75? And that is 60 kilojoules per mole. So I'm going to say that the energy of activation for the reverse process is how much?
60.
60 kilojoules per mole. And I'm going to say that the change in energy for the reverse process is how much? Negative 15 kilojoules per mole. How do you like that? It's like a puzzle, yes? Are you guys excited to have that on the test? I'm dying to write an exciting question. Do you want another one or you think you got it now?
Yeah, we got it.
You got it? Okay, fine, let's do another one. Energy of activation for the reverse process. Energy of activation for the reverse. 100 kilojoules per mole. Changing energy for the forward process. 20 kilojoules per mole. Can you build this? I don't know if math allows us to do such a thing, yes? And mathematically impaired. How big is a chicken?
Oh my god, you thought this.
Is big?
Take a picture. Take a picture and bring it.
Why are you feeding? Why are you feeding it? Chicken food? Really? Why? Give them house food.
Like KFC?
Do you know? Do you guys know what chickens eat? Everything. You know what they love the most? Guess what they love the most? Cockroaches.
Really?
I'm serious. Believe me. Let's say that you have in your house a piece of wood that has been on the floor for a very long time. When you lift it, it's gonna have all kinds of insects underneath, okay? Worms, cockroaches, everything else. You take a couple of chickens and you lift this thing when the chickens are there, and they're gonna go crazy. Them chickens are gonna eat everything that is in there, even if they die in the process. That's how much they like a cockroach. But then you like chickens too, yes? So
That's
you are
good.
what you eat, my friends. I'm guessing this guy likes chicken.
I love chicken.
I do love chicken.
So you'll be eating cockroaches, my friends.
Yeah.
That's insane. You're eating grass would eat a cow.
Yes, you are. But a cow is different. Because you know how a cow gets fat, yes? You know how a cow gets fat?
The hormone, no?
Because you guys think fiber is good for you, yes? When the cow eats that grass, can they digest the grass?
The microbes I just before. The microbes.
The cows cannot digest the grass. Okay? There is bacteria that can break down the cellulose. There is a reason why, and there's a chemistry reason why normal things cannot break down cellulose. Okay? Because it's a beta bond. Anyway, it doesn't matter. When the bacteria breaks down the cellulose, what does it form? You talking, man, I'm smacking right now. So when the bacteria breaks down the cellulose, what does it form?
I assume glucose.
Glucose only. So them cows are getting fat on sugar only. So if you only eat sugar, you will become
A cow.
It's a fact of life. But what do horses eat?
Hey.
Hey.
Hay. And that's the same thing, yes? Nah, I got a little bit more protein. Anyway, horses are ripped, yes? You've seen horses? They eat grass too. They're ripped, but cows are fat. Why is that?
Must be their
They eat the
metabolic.
same thing. They both eat sugar. And they both, one gets fat and the other one is ripped. You seen a horse?
The horses are
You ever
running
seen a
like
fat horse?
24/7.
I never seen a fat horse. All horses that I have seen are either ripped or extra ripped. And the reason for that is because they got a high testosterone.
Oh yeah, they do.
So
Even the females?
this is why you get the testosterone from a horse and you inject it on yourself. Yeah. This is everybody, it's like that.
So even the females?
Yeah, you don't think these females have testosterone?
Of course.
Do you girls have testosterone?
Yes.
Everyone
Of course.
Believe me, you do.
of course.
Okay? That's why some girls are aggressive, you know? But, and guys have estrogen?
Yep.
Not me, I don't got that. All right. Okay, so what was it? Let's see if we can build this. I'm not sure we can build it. So what is it? Energy of activation, forward or reverse?
No, reverse.
Okay, if it is reverse, I gotta start this way, yes?
Yes.
Reverse, I start that way. How much is this?
100.
100 between here and here. This transition state, 100 kilojoules per mole, yes? That was the reverse. And then what?
Change in energy forward is
20.
Change in energy for the
forward.
forward is what?
20.
Let's see. Change in energy is 20 kilojoules per mole. And is this positive or negative?
Positive.
Positive.
Positive. So what that means is that the line for the reactants
Must be
is
lower.
above or below.
Above.
Below.
Excuse me?
Above.
Above.
And go for below.
Above to that is what? Exothermic, yes? This is exothermic. This here is exothermic. While this is endothermic, yes? But before, I was referring to this line. And now I'm referring to this line, so it's the reverse of what I said before. So if I write this line on the top, this reaction will be exothermic, yes? So it is not exothermic, it is endothermic. So where do I draw the line? I draw below this one, okay? Below this one. But before I said when the line is above, it's endothermic. So then I go like this. The difference in energy between here and here is how much? How much did we say this was? 20 kilojoules per mole. And we said this reaction is endothermic, so products minus reactants would give you 20, yes? Bigger number minus little number gives you a positive, yes? Yes or no? So, how much is the energy of activation for the forward process?
It has to be 120.
120 kilojoules per mole. This is forward. And what was the other one? Change in energy for what process?
Forward?
Was this forward or reverse?
Forward.
This was forward? And the change in energy for the reverse was how much?
100.
100 kilojoules per mole. I want to find the other one. Energy of activation for the forward is 120, while the change in energy is
The reverse. Negative 20.
negative 20 kilojoules per mole. You liked that one, didn't you? Now there is an equation. Maybe I should draw this. Okay. What happens when you increase the temperature? Does the reaction get faster or slow?
Faster.
Faster. For every 10 degrees of temperature you increase, the reaction the rate should roughly do what?
Double.
Double. Okay. Now, why is the reason that the reaction goes faster?
The molecules
They start gliding faster.
The molecules have more energy, yes?
Yeah.
They are traveling faster, and when they collide, they have what? This minimum amount of energy, yes?
Yes.
So here's what happens. Let's say this is a fraction of your molecule. Let's say that here is the energy of activation. And let's say this is at a low temperature.
Okay.
Okay? So in here, this is the amount of molecules. In this reaction, what is the side that has enough energy to overcome the energy of activation barrier and to go to product? This is how much? This right here.
Say that again.
These are the molecules. Here's the energy of activation, yes? That's the energy needed. If they pass it, the reaction occurs. If they do have less energy, does the reaction proceed forward? No, it doesn't have enough energy to break the bonds. From this graph here, how many molecules have this minimal amount of energy? That many. Do you see it, yes or no?
No.
What is it that you don't see?
I don't know what's graph A.
I am telling you that this is the fraction of molecules with a certain, let's say, kinetic energy. Here's energy of activation, yes? What is the fraction of these molecules that have enough energy, kinetic energy, to overcome the energy of activation barrier? That amount. These here do not have enough kinetic energy to break this barrier. Yes or no?
Okay.
Now, if I increase the temperature, what happens to this graph? If I increase the temperature, the fraction of molecules now have more energy. Fraction of molecule is now like this. So this is at a
Higher temperature.
higher temperature. So at a higher temperature, then how many molecules were able to overcome the energy of activation barrier?
A greater amount.
It is the ones that are past that point, yes? Because here is the energy of activation barrier. So it is now more than it was before. As a result, the reaction goes faster. Yes or no?
Makes sense.
This is described by an equation called the Arrhenius equation. You ever heard of it before? Arrhenius? This is the Arrhenius equation, a form of it. Arrhenius equation is equal to Ray constant K is equal to something called the frequency factor, or Arrhenius constant A, times E. This is raised to a power, and that power is EA divided by RT. And E is the, what is that called? What is E called? What's ln?
Unit number?
What's ln?
Log base E.
Natural log, okay? Yes, and E is?
Euler's number.
Who?
Euler's number.
Euler's? Who's that?
Mathematician.
Mathematician. Very good. Okay? E is a number, what is it?
2.7 something.
It's your major mathematics?
No.
No? You're not a math major?
No. I would die.
What do you mean you would die? Why would you die? Math kills you?
I would know life.
Smoking kills you, man, not math. Okay, so that's the equation. E is the little e in your calculator, it's a number. And this is raised to that power, minus EA over RT. Tell me, what is this the equation of? Ms. Rodriguez, that is the equation of what? But the graph. How does the graph look?
Bell.
When you took math, how does the graph look?
Bell-shaped curve.
Oh, you haven't taken math. Okay, very good.
Like statistics.
But when you do, you will die. So, okay. It could be exponential decay, yes?
Okay.
Do you see that there is an exponent here, yes or no? Okay, very good. There is an exponent there. So, we cannot understand this equation. We gotta get rid of this thing here, because we do not understand how this equation looks. We're gonna get rid of it because we do not possess mathematical skills to work with it. So we're gonna get rid of this exponent. How do we get rid of an exponent?
ln both sides.
ln everywhere. ln of k. ln of this thing, that's multiplying it, yes? Plus ln of a. And then, since we're doing the ln to get rid of this e here, that drops down, just minus EA over RT. And this is a new Arrhenius equation that has been mathematically manipulated. Is that still the Arrhenius equation? That is still the Arrhenius equation. It's just a different form. Now, the one on the top was exponential. Yes? And the one on the bottom is
Linear.
a line. That's right. How do you know this is a line?
It has the y-intercept.
Because it has the form of something is equal to something else for everybody raised to the first power. Yes? Plus something else. So this is y is equal to mx plus b. This is a line as you expect from this class. So y is equal to mx plus b. When I draw this graph, what's going to be on the y-axis? ln of k. And what is going to be on the x-axis? Okay, does the energy of activation change? Is this number changing?
No.
This number is not changing for the specific reaction. One reaction has one energy of activation and another reaction has a different energy of activation, but this is for one reaction, yes? Does that number change? No, it does not. So this number is not changing. And this R is not rate, this R is a gas constant. Write it down. R is a gas constant.
R.
R is a gas constant.
Is it the same 0.0821?
Yeah, the same gas constant. It depends what units you want to use.
Yeah.
You can use
For ATM.
Yeah.
Okay.
units of energy. Most of the time we use the one that is joules. So 8.1. 1. Okay, good for you. Okay, you apparently know it. So this is not changing. This is not changing. What's changing here?
The temperature.
The temperature is changing. And when you change the temperature, does K change?
Yes.
Hello?
Yes.
Hey, you've been watching the videos, man?
Okay.
What? Yes or no?
Yeah. No, I haven't been watching the videos.
Oh.
But you know, so,
Yes, you gotta decide, yes or
everything
no?
1 over, so it's, alright, so it's, everything is constant, so it's 1 over 20.
Oh, he doesn't even know what I
Yeah, but I
asked.
know the temperature changes, like that's.
Okay, put it this way, guys. If
Okay.
this did not change with temperature, can we build the graph? The graph? If this does not change with that, can we build it? No, we can't. So your answer is, of course. And I told you many times that the rate constant is a constant number, unless you change the temperature. Write it down because it escaped you. Rate constant is a constant, yes, unless the temperature is changed. Guys, if we have missed here any days, write them days here and put the line underneath it, okay, if you're here. Yes, you got it? So what day is today? 18? So we're missing a couple of days here. I don't suggest you do it, okay? Well, you let a girl put the dates there.
Alright. More.
It's a problem, you're gonna have to ask her now.
Let's put the 18 right here, like right on the next box.
No, I said not on the next box, man. In fact, pass the thing to a girl. Okay, so, guys, when you change the temperature, what happens to K?
Change.
K changes. Okay? So here I am going to write 1 divided by T. Okay? The units on this will be in Kelvin. Is that a positive slope or is that a negative slope? Positive slope or negative slope?
Negative.
Negative slope. It will begin like this. And what is the slope here equal to?
The energy of activation over the rate constant.
It is equal to minus EA over R. Not X, yes? You don't put X. Slope is everything else except X. Minus EA over R. It is negative. Did you just say Y? What's this here? This Alanove. We already did this before for kinetics, yes? Yes? Integrated rate law? You should know how to do this already. If you don't, that's because you didn't learn before. And if you don't learn, you can't go ahead with your future. Okay? Right? Yes or no?
Yeah, pretty much.
Right, but this is a special class because you guys are very good. So if I had this number, how do I find A? If I have this number, how do I find A? Let's say this number is minus 25. How do I find A? E to the minus 25, yes? It's not. Ln of A is equal to minus 25. This A is not minus 25, yes? I gotta get rid of this thing, e to the
Right.
minus that. I mean, e to that is just a, and e to the minus 25. That's how you find this number. Okay? Very good. So let's say I wanted the energy of activation for a reaction. What would I do? I will plot the ln of K versus 1 over T. And the slope of this line will be equal to what? The slope, or M, is equal to what?
Negative EA over.
Minus EA over R. Where do I get a slope from? From graphing stuff, yes?
Mhm.
Where do you graph things? In a graphing program, yes? Okay, graphing calculator, absolutely not. Okay? You will get this from a graphing program, and the program is gonna give you mx plus b, okay? And you are going to use this number to calculate the energy of activation. So that's that number. It will be what type of sign?
Negative.
It will be negative. The slope negative, yes or no?
Yep.
Slope is negative. Negative slope times that negative is gonna give me what? A positive, because energy of activation needs to be a positive number. So I am going to get M, I already took away the minus from here and that minus. M times the gas constant will give me the energy of activation, and this M is the slope. So how would you find the energy of activation for a reaction? You will run the reaction, and you will do what with the temperature? You will change the temperature, you will calculate K, and you will plot it, and the slope will be multiplied by the gas constant.
What about the negative?
What?
What about the negative?
Huh?
What about the negative?
Which negative? This negative?
Yes.
The slope is negative, yes?
Oh,
So the negative from the slope and times this negative from the equation is positive. So, this gas constant, the units on energy of activation are in kilojoules per mole. What gas constant am I going to use? The one that has joules in it. Yes, which is? Which gas constant has joules in it?
8.34.
You don't know? Me neither. I'm not taking the test, I don't have to know. You guys are the ones taking the test. I don't care to know anything of this stuff. Okay, why don't we do a problem? You want to do a problem?
Yes,
On what?
on this.
Guys, how do you calculate K? How do you calculate K? Yeah, but tell me, if you don't know K, how do you calculate it? No, you can't use the Arrhenius equation.
Use the integrated rate.
I mean, you could if you had everything else, but you want K, so you can't use the Arrhenius equation because you don't know EA.
Use the rate law.
Yeah, you double count.
We gotta use the rate law. So in order to find K, we need to use the rate law, yes? Yes or no?
Yep.
In order to find this K, we need to use the rate law. And before we can find K, what do we need to find? M and N. We already did problems and then M and N, and you did some in the lab too. Okay? So we're gonna find K. And then what else is gonna happen? We're gonna change the temperature, yes? So at T1, we're gonna plug in the numbers to find K for a certain temperature, and then we are going to increase the temperature. What's gonna happen to this number? This number is going to change, yes? It's going to increase, yes. That number will increase. Is the concentration going to stay the same? We could leave the concentrations the same. Are the orders going to stay the same if I increase the temperature? Yes. Concentrations stay the same, orders stay the same. What happens is the rate changes. As a result, what happens to K?
Changes.
It changes too. Does it increase or decrease?
Increase.
K increases too, because the rate is like this, right? Rate divided by those things.
Then you need to know the exponents.
Yes, you do need to know the exponents. But no matter what, whether you know them or not, what's happening as the rate increases? Does this change? No, it does not. How much does that increase by? Huh?
How much does K increase by?
I'm telling you, you guys should have taken math, okay? When you guys get kids, okay, when you have kids, what are you gonna teach your kids?
Chemistry.
No chemistry, okay? Not teach them chemistry. You teach them two things only, English and math. You don't know either one of them, do you? I can only teach mine math, okay? That's what I'm doing. Because I can't teach her English, right? Anyway, I'm teaching her Spanish. So let's say that I raise that to that power, and it's a 2. I raise that to that power, it's another 2. Yes? And let's say this here is a, let's make it a hard number, 20. Yes or no? Whatever K is equal to, it doesn't matter. This is at temperature 1. At temperature 2, I increase the temperature by 10 degrees. The rate roughly doubles. What's double of 40? I asked a simple question. What's double of 40? 80. Okay, good. And double of 20? 40. I don't know why you guys think that's a weird question. So, the rate increased by 2 times, yes? And the K, according to this that I have here, has increased by a factor of 2 as well, yes? Okay. So, what it is the K is changing, because as you increase the temperature, what happens to the rate? The rate is changing too, okay? The change is not linear, okay? The ln of the change is linear, but the change is not linear, it's exponential. But it doesn't matter, okay? What matters is that you understand that I get K from the rate law and the different temperatures. And then I am going to do the ln of K, yes? Versus 1 over T. Where did I get this K from?
The rate.
From the rate law.
Yes.
And this temperature? I changed it, yes? I changed it on purpose. Most of the time by 10 degrees. Okay? So, here's what's going to happen. I'm going to tell you. Calculate the energy of activation for a reaction, and can I erase this? For a reaction, and this is how it looks. Temperature in Kelvin is 462.9, 472.1, 503.5, 524.4. Okay? And the ln of K. Guys, is this K and this K the same?
No.
This K is Kelvin, yes? And this K is rate constant. I found the rate constant and I took the ln of that rate constant. And it is a number. And the number is this, let's say. For the first, 10.589. For the second, 9.855 for the third, minus 7.370. Tell me, where did I get these numbers from? From the rate law. I calculated K from the rate law. It is a number, and then I did what with that number?
You LN'd it.
I said ln of that number is a key on your calculator, yes?
Yep.
And I got these. Can I plot this already?
Yeah.
Can I plot this?
Yep.
What do I plot?
1 over t and
1 over t. So I gotta get what with the t? I have to do 1 over t, yes? So I gotta do 1 over t. So I hid that from you. Let's see if you'll notice. So 1 over t is, let's say, this number. And what am I going to plot now?
You're still doing ln of k versus.
I am doing ln of k, else on what axis?
y.
Y-axis versus
Wait,
1 over t. This is what I am going to plot in Excel. Yeah.
why is it in Fahrenheit? Why did you put?
What happened?
Why is it in
That's
Fahrenheit?
Kelvin. Just
The T right next to the T. Yeah, yeah.
Are they all to the negative third, or is the first one?
Say that again.
It was supposed to be K, not F.
It is a king.
That is
it
okay.
is okay, just a little off. That's all.
He is meaning to ask. This is K, man. It's not obvious to you that this is K. It's not F. F is a grade you're gonna get in this class.
Oh, man.
But what is this? Look. No, you're right. Okay. Let's fix it. I'll fix it.
It's very stylish.
Got better?
Yeah.
It did look like an F. Okay, it's fine. So it is K. Okay. All right. Good. So now what?
Professor, are they all to the negative third, or is the first two?
Oh, to the negative third. But it doesn't matter. You're not gonna graph this, yes? I mean, go home and graph it. Okay, but I'm not gonna ask you. On the test, am I gonna ask you to graph it? Some professors do. Do you want me to ask you to graph this on the test and calculate the slope of that graph?
Nah, not really.
I am going to do that in the lab, but not in the lecture, okay? So calculate the energy of activation for that data, okay? Data was plotted. So I plotted the data. And let's say I am saying a graphing program, you can do this by hand, yes? You can do it by hand. How do you calculate the slope by hand?
Finding points.
2 points, yes? Which 2 points am I going to find?
First and last.
First and last of the graphing points?
Any point on the
You can use
line.
any.
You can use any points.
Do you guys know how to graph?
Yeah.
You do? I bet money you don't.
I'm not sure.
I definitely wouldn't stop calculus if I didn't.
Okay, this is what you do, yes? I have a point here, I have a point here, and I have a point here. And the best line of this, best line is, that is the best line. Yes? Do I use this point and do I use this point to calculate the slope of this line? Hello?
No.
No, you do not. You never use the points you plot to calculate the slope.
We use the best
Because the points you plotted may not land on the line. So what are you going to use? You are going to find
lines.
whenever you can read them numbers. And you're going to go here and you're going to say, okay, I can read this number and I can read this other number, and those are the numbers you use. The ones that you can read that fall on the line. Yes? Not the first and the last number. No. Of course, if you do not want to draw the best line, then you can use the first and the last number, right? If you don't want to draw it, but that's not right. Yes? So that's why I say a graphing program provided this equation. provided this equation. If I can find it. This original problem is not like this. Okay, whatever, it's. So calculate the energy of activation. What's the energy of activation?
Yes, when it is,
The what? Go ahead, LeBron.
yes, when energy, for the action.
Okay, but not from here.
But we don't have a bell-shaped curve. So you don't want to do that.
So-
Let us know about the rates.
Okay, we have the slope, yes, the slope, because we plotted this data. We plotted this data. The slope is equal to minus EA over R. I have the slope, and I am going to solve for EA, so this is going to be MR is equal to minus EA. And when I plug in the numbers, this is the slope. Oh, I was supposed to put X here, yes?
Yeah.
Okay, put KX, okay? I forgot. So the slope is not including the X, yes? Minus 1.9 times 10 to the fourth. And I am going to multiply that by what? Gas constant, what's the gas constant? 8.314. Let's just leave it at 8.31 joules
Per,
Mole Kelvin, I think.
per mole Kelvin.
I'm pretty sure.
You don't know the gas constant? Neither do I, okay? No big deal. If you don't know, what do? Google it, okay? This up here is in what? This is in Kelvin. Now, if you do it in a graphing program, it's not gonna give you the units on it, okay? It's not gonna give you the units. How do you know the units on a slope? Ms. Rodriguez, how do you know the units on a slope? Huh? You're tired. Why are you always tired in the morning? You just woke up? Do you work at a strip club?
No, that Grey's Anatomy. No.
Oh, Grey's Anatomy.
3 in the morning.
Okay. Grey's Anatomy. That's horrible. Okay. What's the slope, guys? Slope is equal to what? Tell me what I write to find the slope. Change in
Y.
divided by.
Change in X.
Very good. What's the change in y for the ln of k versus 1 over t? No units, yes? No units. The ln of units, no units for the ln of k, yes? And what are the units on 1 divided, on the y-axis?
That goes to the negative 1. So it goes for
So this is on the bottom of the bottom, which is on the top. So the units are units of k. So the slope has units of k. That's how you find them. You plug them in. Okay? This doesn't have units, yes? But this does have units. So that's why that's k. And when you find here this K cancels with that K. And this will give you minus EA. And this minus cancels out with that minus, yes or no? And you are going to have energy of activation is equal to what number? Tell me.
15, yeah, 1.57 makes sense in the negative, 10 cents in the,
1.57 you said?
yeah, 1.57 cents in the negative third.
Times 10 to the negative third?
Uh-huh. I mean, 10
Get
cents third.
Get that third.
Sorry.
Huh?
Yeah, it is.
I'm telling you, why are you using the graphing calculator if we know that you don't know how to use it? It's not the first time you make a mistake, yes?
No,
Is
it's
it?
not. What I'm using.
That means you don't learn from your mistake, man. Stop using that calculator. What is it? To the fifth or to the third? Units. Huh?
Joules per mole Kelvin. Joule per mole.
Sure, per mole Kelvin, but the Kelvin canceled out, okay?
Never mind, sorry.
Kelvin canceled out. And most of the time, energy of activation is a given in joules. Have I been talking about energy of activation in joules? No. Energy of activation is most of the time given in kilojoules. And the reason for that is because we don't like to have these exponents, right? So let's change this to kilojoules. What do I do? Joules, kilojoules.
Yeah.
A kilo
You have
is 10 to
1,000.
the third, yes? Everybody knows what a kilo is, right?
Yep.
You've been selling it? All right, how much is this? 157 kilojoules per mole. Okay? Yes or no? You have a question like that on your test. Good?
Yeah, no,
That's all right, man. I'm just guessing. I gotta pick on you and her.
You're entitled, man.
I gotta pick on somebody.
So
Yes.
we will always be given an equation like that.
You can be given an equation or you can just be given the slope.
Okay.
Guys, in the lab, how are you going to find the energy of activation? Like that, yeah. Like that. By plotting ln of k versus 1 over 2.
We're done.
Oh, we're not done. Chill. Why done?
We have 5 minutes.
Exactly, we're gonna take advantage of them. You were 5 minutes late. So you take 10 minutes from me in every class. Okay. That's the Arrhenius equation. Write this down. That Arrhenius equation is used when you have a lot of data that you can plot. Next class, I'm gonna give you a different Arrhenius equation that you can use when you have 2 points. Let's talk about something called the mechanisms, because you're gonna enjoy this. A mechanism. A mechanism is a detailed picture of what is happening in your reaction. What bonds are being broken, what bonds are being made. What's a mechanism?
A detailed picture of what's happening in your reaction.
Very good. Mechanism is broken down into something called elementary steps.
Isn't it like pressure, like if you...
Huh? They are broken down into elementary steps. Okay? And of course, the word elementary means what? The most basic of all kinds, yes? Elementary steps are those steps that occur in a single step. So elementary step are single steps. So, A gives you, let's say, 2B. Now, elementary steps can be unimolecular, bimolecular, or termolecular. Okay. This elementary step has one reactant molecule. And when it has one reactant molecule, it is unimolecular. Because it has how many molecules?
Single one.
One reactant molecule, so it is unimolecular. What order should that be? First order, second order, or third order, or zeroth order? This process is unimolecular. Uni means what? What number is uni, guys? One. So
first order.
unimolecular is first order. And if it were like this, 2A gives you B. What this process would be what?
Bimolecular.
Bimolecular. How many molecules? 2 molecules. What order should that be?
Second order.
Second order. And if it were 3 of them, that would be third molecular. Third molecular.
Third.
Yeah, not T-U-R-T. T-E-R-T.
Why third?
You gotta have, that you have to ask an English professor. Why you use uni, bi, and ter. It's related to English. Like primary, secondary, and tertiary, right? I can't say primary, secondary, and third airy, right? All right. So let's say that we have, let's do it next class.